We know that a sequence is an arrangement of numbers in a definite order according to some definite rule. Take a look at this sequence. Note that every subsequent term is 4 times the previous term. Such a sequence where every term after the first term is obtained by multiplying a non-zero constant to the previous term is called a geometric progression. The abbreviation GP is commonly used to refer to a geometric progression. The non-zero constant is called the common ratio of the GP and is usually denoted by R. So, in the above GP, the common ratio is 4. Now, take a look at this geometric progression with common ratio -2. The first term of this GP is 4. Let's call it A. By definition, we know that the second term is given by the product of the first term and the common ratio. Similarly, the third term is given by the product of the second term and the common ratio. The same approach may be used to find subsequent terms. We can generalize these observations to conclude that a geometric progression may be expressed as shown, where A is the first term and R is the common ratio of the GP. Thus, the individual terms of a GP can be written like this. We thus see that the ratio of every term to its preceding term gives R. Now, let's multiply these n-1 ratios. On simplifying, we are left with the ratio of Tn to T1 on the left-hand side and R raised to the power n-1 on the right-hand side. Rearranging this expression and using the fact that T1 is equal to A, we get an expression for the nth term of a GP, where A is its first term and R is the common ratio. Let's now look at a few examples to see how this expression can be used. For the given GP, we need to find the sixth term. We see that the first term of this GP is 5 and the common ratio is 3. Using the expression for the nth term of a GP, we can find the sixth term by simply substituting n as 6 in the expression and using the values of the first term and the common ratio that we observed. On simplification, we get the value of the sixth term as 1215. Simple, isn't it? Look at this example. We are given the third and fifth terms of a GP and are asked to find its first term. Again, using the expression for the nth term of a GP, we substitute the provided values of the third and the fifth terms to get two equations in A and R. On dividing equation 2 by equation 1, we get R squared is equal to 16 by 9. Using this value of R squared in equation 1, we get the value of A as 9. Thus, the first term of this GP is 9. Okay, now let's try to derive an expression to find the sum of the first n terms of a GP. Consider the general representation of a GP as shown. We denote the sum of its first n terms by Sn. Let's call this equation 1. Now, we multiply equation 1 by R. Let's call this equation 2. Now, we subtract equation 2 from equation 1. We can now divide this resultant expression by 1 minus R, which is not equal to 0.